Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my brilliant co-host, Victor. Before we dive in, I want to remind our listeners that your support means the world to us. If you're enjoying the show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more developers like you.
Absolutely, Sheila. Your feedback keeps us motivated and helps us improve the show. Now let's get into today's topic, which is part of our Decentralized Storage Systems chapter. We'll be discussing the CAP theorem in the context of P2P systems.
That's right, Victor. And to kick things off, I have a brain teaser for our listeners. Here's the quiz question. In a P2P system, which two properties of the CAP theorem would you prioritize for a real-time collaborative document editing application?
Ooh, that's a great question, Sheila. It really makes you think about the trade-offs in P2P systems. Without giving away the answer, I think this question will help our listeners understand the practical implications of the CAP theorem. It's not just theoretical, it has real consequences for system design.
Exactly. Now, before we dive deeper, let's make sure we're all on the same page. Victor, could you give us a quick rundown of what the CAP theorem is?
Of course, the CAP theorem, also known as Brewer's theorem, is a fundamental concept in distributed systems. It states that it's impossible for a distributed data store to simultaneously provide more than two out of the following three guarantees: consistency, availability, and partition tolerance. Consistency means that all nodes see the same data at the same time. Availability ensures that every request receives a response, without guarantee that it contains the most recent version of the information. Partition tolerance is the system's ability to continue operating despite network partitions or failures.
That's a great explanation, Victor. So, if I understand correctly, in a P2P context, we're often dealing with systems that need to be partition tolerant by nature, right? Because peers can join and leave the network at any time.
Exactly right, Sheila. In P2P systems, partition tolerance is usually a given due to the dynamic nature of peer connections. This means we're often left choosing between consistency and availability when designing our systems.
I see. Could you give us an analogy to help visualize this concept?
Sure. Think of the CAP theorem like a triangle, where each corner represents one of the properties: consistency, availability, and partition tolerance. Now imagine you're standing inside this triangle, and you can only be close to two corners at a time. As you move towards any two corners, you inevitably move away from the third.
That's a helpful visualization. Thanks. Now, let's talk about some real-world implementations. How do popular P2P systems handle these trade-offs?
Great question. Let's take BitTorrent as an example. It prioritizes availability and partition tolerance over strong consistency. This means that you can always download parts of a file from available peers, even if the network is partitioned. But you might not always have the most up-to-date information about the entire swarm.
Interesting. And what about systems that might prioritize consistency over availability?
A good example would be a P2P-based cryptocurrency system like Bitcoin. It prioritizes consistency and partition tolerance over availability. This is why Bitcoin transactions take time to confirm. The system is ensuring that all nodes have a consistent view of the blockchain, even if it means some transactions might be temporarily unavailable or slower to process.
I see. So it really depends on the specific needs of the application. Are there any common misunderstandings about the CAP theorem that our listeners should be aware of?
Absolutely. One common misconception is that you have to choose only two properties and completely give up the third. In reality, it's more of a spectrum. You can often make trade-offs to get a bit of all three, but you can't maximize all of them simultaneously.
That's a crucial point, Victor. Now, let's talk about best practices. How should developers approach the CAP theorem when designing P2P systems?
Great question. The key is to clearly define your system's requirements. Ask yourself, what's more important for your use case? Having the most up-to-date data, consistency, always being able to read and write data, availability, or continuing to function when the network is unreliable, partition tolerance. Once you've prioritized these, you can make informed decisions about your system's architecture. For example, if you need strong consistency, you might implement a consensus algorithm. If availability is crucial, you might use techniques like eventual consistency or conflict-free replicated data types, CRDTs.
That's really helpful, Victor. Before we wrap up, do you have any interesting facts or anecdotes about the CAP theorem?
Actually, I do. The CAP theorem was first proposed by Eric Brewer in 2000, and it was initially quite controversial. Many people tried to disprove it, but in 2002, Seth Gilbert and Nancy Lynch of MIT published a formal proof of the theorem. It's a great reminder that even seemingly intuitive ideas in computer science often need rigorous mathematical proof.
Fascinating. Now let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. For a real-time collaborative document editing application in a P2P system, you would typically prioritize availability and partition tolerance. This allows users to continue working on their documents even when some peers are disconnected. Consistency is often handled through techniques like operational transformation or CRDTs to merge changes later.
Excellent explanation, Victor. To sum up today's episode, we've learned about the CAP theorem and its implications for P2P systems. We've seen how different systems prioritize consistency, availability, and partition tolerance based on their specific needs. Remember, it's not about choosing just two, but finding the right balance for your application.
Absolutely, Sheila. And as we always say, the best way to truly understand these concepts is to apply them in practice. So we encourage our listeners to experiment with different P2P architectures and see how the CAP theorem plays out in real-world scenarios.
That's great advice, Victor. And to our listeners, we hope you found this episode helpful. If you did, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us keep creating this content, and don't forget to subscribe and rate the podcast. Until next time, happy coding.